Okay, so today we're doing problem 1888, minimum number of flips to make binary string alternating. So we got the binary string and we can do two operations. One is shift the characters, so we remove the first one and add it to the back. So basically we do left shift, cyclic, and operation 2 is flip any value. And now we should say minimum number of type 2 operations so that it becomes alternating. Uh, okay, so what is the size of string? 10 to 5, right? And then, so we want probably linear, I'm guessing. So, since we can move characters, right? Moving is just a cyclic shift, so there's only n different cyclic shifts. And if for each cyclic shift we could figure out the number of operations needed in constant time, then we basically solve the problem in linear time because we just pick minimum of that. Now how do we solve that, right? So basically we do however many we want of this, and then how to calculate for a string minimum number to operations. Well, let's ignore zeros because who cares. And let's say we got this string. So what we want is to have all ones on either even or odd positions, right? Here we don't. So that's the first thing. That there I mean, first thing is that, okay, so we would need to lower the smaller number of even odd count, which in this case is odd, since there is, if we consider indices, then this one is at index 1. So we would need to flip one there and add one to odd. So that's two operations to get to free 0, right? And then one problem is that we might actually have too many. Like here we have, we can only have too many in one department, right? So basically you want to you want to delete the smaller number and then you want to change the larger number. I guess doesn't really matter, because let's say I have like 5 and 3. Okay, that doesn't matter. If I have 5 and 2, I could do -5 plus 3, that's 8, or I could do, yeah, that's probably better. Because either way you make the distance, so you just make an extra distance. And what I'm thinking about is that because if I have some count, right, and then I don't know, I have like 2 and then I have like 5 and I want 4, right? So we could either decrease 2 to 0 and decrease 5 to 4, or we could do this to 4 and then 5 to 0. Problem is, if we move 5 to 0, we basically do 4, right? We decrease by 4 plus this extra part, and then 2 does this part. But if we do it the other way, right, then we do this part and then this part only, right? So we do less than or equal to what would just this 5 do itself, let alone the increase of 3. So in any case, you still want to decrease the lower number and then whatever update the higher number to, because if it would be like 3, then you would need to do whatever, +1 here and whatever. Now the question is, okay, so first edge case is we have even length or odd length string. There we consider two options, right? So we could have like for a length of 3 we could have 2 1s and 1 1, right? Okay, but that's just two of these things. And then finally, how do we deal with, okay, so let's say we calculated number of operations, and how do we deal with shift? Well, only thing that the shift does is just flips the odd and even count of 1. So technically, we don't even flips it, so technically we just have to try 1 shift or 2 shifts to the original, shift by 0 and then shift by 1, I think. But that depends, because then you would have, let's say I would have 1 and 1 here, so I have odd even, and then I have even. Okay, so it's a bit trickier. For even length strings, it goes from odd to this, just switch position, and this goes to here. But for odd, if you cycle, depends on what you cycle. If you cycle 1, then everything else flips, and that 1 stays the same. So okay, and then if there is, oh my days, okay, so I guess it's 6 minutes to just say all steps. So let's grab the size, of course. Now solve shift, right? So you could get count for char in S if, or like count of char is equal to 1 plus equals 1, whatever. Let's see if this will work. Okay, it works. Okay, we are getting the counts. That's great. So basically now def solve shift. I mean, let's just do count, why not? And then next character, because for evenly odd length we care about the character. And now for I in range n, solve shift count si will be the one moving there. So technically, yeah, we want to do n-1 shifts. Meh. So first shift is nothing. Si if I else none, and then we just keep some answer, and it could take how many? Could take at most like n operations, I guess. Whatever. I guess. Okay, so for a shift, yeah, I guess we need to update counts here. I mean, I guess we are doing all and shifts after all. And then count is equal to count 1, count 0 if n is even. Else it's a bit more complicated depending on the count, so I don't even want this character, I guess. Oh, but that's odd even count. Oh. Count of so count is equal to count of, because I'm odd even counting once. Okay, that's fair. And then if we have odd length, then it depends on the, so all shift then we want to do send even is equal to count 1, count on is equal to count 0. Now the problem is I swap the counts, but in reality, because if I have and then if SI is 1, then we want to do something so the parity of that doesn't change. So basically we subtract so even position is odd. No, but if SI was 1, that means that we supposed to so we have 1 less in even, we take it from even and then we give it back to even. So we take it there and then odd is equal to, so even is equal to that. So odd is equal to even minus 1. And then count even. I mean, technically they gained. So I guess okay. I guess maybe we'll see if it works. And now given counts and then like the length, then I have to do something, right? So if count 0 okay, and then so we somehow swap that out. So I mean, let's pretend it's even, right? So let's make logic for even. Basically what that means is that ans is equal to count 1 plus ups of n half minus count 0. That's fair. And then if we are 2. So you put the smaller to 0 and larger to there, and then if n percentage 2, then ans mean ans count 1 plus ups n plus 1 divided by 2 minus. Okay, I mean this is a bit excessive for a medium, to be honest. What the hell? How you do this in 2 operations? What? When will you need 2 flips only, brother? So we'll have 1 0. So you just, I mean, you will have 1 0. What? Then you can make it into 1 0 1 0 1 0 0 1 0 0, and I'm missing something. So 101 1001 1001. Okay, that's fair. Let's do all shifts. Fair, I guess. Okay, then it's this. How many even? That's 4 4 11 7 8 9 0 no 0 1 0 1 0 0 1 0 0 1 1 1 0 1 0 0 1 0 0 1 1 0. Okay, I guess that's, I don't know if that's correct. So now out of these there is one possibility where you can flip it in 2. Well, here you would have to flip. No, let's print dance. Or like, let's print this. There must be something simpler than what I'm doing, because that is crazy. They say everything takes 4 operations. How come? Odd, even, odd, even, odd, even, odd, even, odd, even. It's weird that count is always like that. It's a little sus. So 0 1, so that's like even, odd, even, odd, even, odd, even, odd, even, odd, even. Yeah, that's fair. And this should just alternate. So that's even, odd, even, odd. So that's 1 1. even odd, even odd, even odd. Okay, these are same. This should flip. Why is it not flipping though? I mean, what the hell? So what that does is you take out one, you swap, and then you add one, two. I don't understand this at all, bro. I'm too fried today. How is this the most frequent Google problem I have not solved? Did I really solve every single relevant problem that there exists, or what? That's crazy, dude. I have only 24 minutes left in real interview. I mean, N is 11 and this is SI1, so I mean I understand it, but oh, because here I'm modifying it. Of course. So let's not make a copy. Or let's make a copy, shall I say. Oh, still wrong. That's great. Is it at least swapping the values? What? Come on, mate. What are you doing? Okay. I was worried there for a sec. I became stupid. Let's see. Come on, man. Really? Really? Oh my god, bro. That's ridiculous. How am I supposed to even debug this? Okay, I can now erase this. And then let's see. 39, so there is 20 what? So how can you make 21 after that few shifts? Because you have to do 2 and no, it's how long is it? What the hell? 55. Okay. So half is like what, 27? But there is no way it's no, that's no way. 0, 1, 2, 3, 4. I don't want to debug this so hard. So let's do the temp is like s from I plus s up to I, and then cc for char in for I in range. No, like for if cc index percentage 2 plus equals 1 print cc. Let's see. 13, 9, 9, 13, 13, 9, 9, 13. So this holds. So my calculation is off. So half is 27 minus count 0, so that's 13. That doesn't quite work out for some reason. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. What? What? It's 21, bruh. Did I miss anything? Pick any character. If index doesn't equal what? So if that's true, then this should also be true. Then ops plus equals 1, print index ops is 0, I mean, I guess I can move it here too. 0 operations, that's crazy. Let's cap. That's capping so hard, bro. Yeah, because that's a bool and that's an int. That's why. A very strongly untyped thing. 27 operations. How did you come up with that, bro? One, 3. Wait, what? Because it's temp index on my days. So it's 22 operations. Somehow it's 22. That's weird. How that possible? 2. Oh, I know how, because I can't just swap it out. Okay. Okay, that sucks. Well, if n is even, right, then, I mean, if n is even, you can swap it out, right? So, and if n is odd, no, because that's, so you put evens at that, and then this there, so I have to swap this. So I do 0 1 here, and then only thing I do is if n percentage 2 is this, like that. Ooh, now it sucks completely. That is ridiculous. That's straight up ridiculous. Nah, I'm supposed to do this. Let's go. Okay, let's see if this passes. This whole thing is unnecessary. And these two. I'm still printing something. How many wrong? Something is wrong. It shouldn't run for that long. Time limit exceeded. You have to be kidding. That is ridiculous, brother. What the hell? Oh, because I'm doing this. Oh, and I'm doing this. Oh, okay. Okay. 377. I mean, we could optimize this. Fair enough. Then we erase this. As such, this is what you call an implementation pane. Or how was it even called? I don't even remember. That's crazy. Should be renamed. Okay, should run faster. Okay, only marginally. Maybe, I don't know. Whatever. Okay, let's see. Editorial 2-line solution. Prefix sum plus suffix sum. What is that? What? What the hell is that function? Prefix odd, prefix even. I mean, I can do it in all one. Oh my god. Okay. What are they saying? Since operation 1 is reversible and does not change character values, alternating string can only be obtained from another alternating string using therefore, after completing all type 2 operations, the string S must already... What? What? Okay, that's just this is the worst solution I have ever seen, ever. That's ridiculous. That's 13 uploads with 550. That's horrific. Let's see this guy. Ooh, sliding window. 7 lines of code with O1 memory. You kidding, right? Virtual sliding window. I guess fair enough, but writing a Python like this should be banned. They append the string, but you are appending, bruh. What? That is ridiculous, man. That's ridiculous. Okay, I'm happy I got it. I can go shower and go to sleep. So, how do we call this? It's not even sliding window like a greedy. Time space 01. Okay, so intuition. What was my intuition? Yes, either a form of for now, let's pretend the length of the string is even. Then alternating string has either form of, okay, for a given string we can calculate the number of operations to get an alternating string as min count 0 count 1 plus ups and divided by 2 minus max count 0 count 1. Count 0 is count of 1 on even positions and count 1 is a count of ones is D. On odd positions. Okay. formula means we change all ones to zeros for the even/odd we change either all ones to zeros, either all even or odd ones to zeros, and then the other ones will have to have count of n squared. Okay. Now that we have an answer for the initial string, how can we use this to calculate answer? Okay, so next, notice that shifting that type 1 operation is just a cyclic shift of input string, which can only give us n unique strings, so we only need to consider n unique shifts. How can you use this to calculate answer for the next shift in O1? For even length string, the odd and even count of ones just flip. Odd length string, the counts we first subtract 1 from even, and odd length string with 0 at the start. The odd and even counts of ones just flip. For an odd length string starting with 1, we first subtract 1 from even count, we first subtract 1 from even count, then swap them, and finally, since shift if first character is 0 only, swaps the counts, add 1 back to the new even count, since the one from start goes to end, but for odd length strings start and end index are both even. Okay, so shifts. Answer for next shift. Okay. again use the formula to update the answer. So we remove that. ON, since we first get the counts in ON by a single pass of the entire string, and then we move all and then we update answer for each cyclic shift in O1, which is ON in total. O1 since we only use a couple of variables. Okay. Now, odd length string formula. Now, one thing I conveniently skipped was the formula for odd length strings. Alternating strings of even length are of odd length have a form of 101 blah 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 or 010 blah blah 10. Okay. Our options are either decrease the lower count of odd/even to 0. No. Decrease odd count to 0 and make even count equal to L floor fraction n squared air seal should be seal L seal. Does that work? Yeah. Option 1. Option 1 or this. Option 2, right? And then decrease even count to 0 and make the odd count equal to okay. Longest editorial for the stupidest problem. This is ridiculous. Okay. And I'm going to lose my streak because there is a dogshit implementation art problem. So see you tomorrow.